How hospital isolate patients with infectious illnesses. There is one room for patients who susceptible to infections by others, away from the other patients, visitors, and healthcare staff. Negative room pressure is an isolation technique used in hospitals and medical centers to prevent cross-contamination from room to room. It includes a ventilation that generates negative pressure, pressure lower than of the surroundings, to allow air to flow into the isolation room but not escape from the room. As shown on our 3D model isolation room was divided into 3 parts. The patient room, the anteroom or filter room, and the toilet. Let's trace out how the supply and exhaust air applied in the isolation room. On the supply air duct, a branch connected for an air outlet for the hallway. Supply air means positive air pressure, so this air outlet in the hallway is for ventilation. After that first branch, a VAV or variable air volume device was installed. This is to control the positive air pressure going to the isolation room. VAV has a thermostat controller. From here you can adjust airflow inside the room. After the VAV, another branch was connected and supplying positive air pressure to the anteroom. Anteroom is a control area in which the transfer of supplies, equipment, and persons can occur without contamination impacting on the surrounding healthcare areas. After the anteroom positive air supply, comes next the patient room. Isolation rooms have fairly high rates of air exchange relative to other patient areas. This applies to both ventilation air supply and exhaust flow rates. Positive air supply to patient room should have a HEPA filter. HEPA stands for High Efficiency Particulate Air. HEPA filters are used in applications that require contamination control. Now, we are going to the main subject, on how isolation room can be in negative pressure room. A dedicated exhaust system should be provided to the negative pressure isolation room. To maintain negative pressure, the exhaust system removes a quantity of air greater than that of the supply air. Exhaust air duct was installed in 2 areas. One in the toilet, and one in the patient room. The exhaust air duct should be independent of the building exhaust air system, to reduce risk of contamination due to backdrafts, and should discharge away from staff, visitor, and patient areas. In monitoring the negative pressure inside the room, a differential pressure sensor should be installed. By this sensor, we can determine whether the room is safe or not safe to enter. Example of this monitoring sensor is the Siemens room pressure monitoring. It was a differential pressure sensor which measures both positive and negative pressure at the same time, and calculate the difference between the 2 conditions. As we are monitoring negative pressure, alarm will appear on the screen whenever negative pressure failed inside the room. This air hose is connected to the low side port of the room pressure monitoring. It sends the positive air pressure from the supply air diffuser in the hallway, and another air hose inside the room. This is connected to the high port of the room pressure monitoring. This one will sense the negative pressure inside the room. A negative room pressure set point will range at negative 2.4 to negative 12.4 Pascal. When negative pressure falls below negative 2.4 Pascal, room pressure monitoring will give an alarm. Nurses and other medical staff should pay attention when there's an alarm. Alarms are caused by some factors that can be reset by doing some simple task inside the room. Some cause of alarm are technically, and need a presence of a technician. Let us see what are these factors that cause an alarm. As you can see on the floor plan of an isolation room, all doors should properly close to obtain good negative pressure inside the room. The arrows represent that the exhaust air is greater than the value of supply air to have a negative pressure. If we open the door A, positive pressure from the hallway will enter the room. So the positive pressure inside the room becomes greater than negative pressure. And at this point, an alarm will be activated. If we open door B, it should be no alarm. Because ante-room is positive pressure. Unless door C is not properly close or open, positive pressure will enter the patient room from ante-room door, and then alarm will be activated. Even door B is closed and door C is open, positive pressure from ante-room will activate the alarm inside the room. Entrance door and ante-room door should properly close, or properly sealed to prevent the entering of positive pressure inside the isolation room. Although toilet is in negative pressure, it cannot trigger alarm, besides it can help the patient room for exhausting air. Another cause of negative pressure failure inside the room is problem in exhaust fan. If exhaust fan is defective, there will be no air exhaust inside the room. If all doors are closed, and still room pressure monitoring is in alarm. At this point you should call a technician to troubleshoot the problem. Please consider giving this video a thumbs up. Every time you hit the like button, you help us growing our channel. Subscribe as well to notify you when there's new video uploaded. Thank you very much and have a good day.